So, you've taken the Cornell notes, and now we want to just jump into doing some examples so that you can understand how to utilize the information that we've done in the Cornell notes. So in the Cornell, we've talked about variable and what an algebraic expression is, and we have also filled in the chart with the different words that mean different things. So when we are translating sentence from fragments into algebraic expressions, we want to remember that chart that we had. So for more than a number. So first of all, it's important to find the key term that tells you what operation. So if it says more than, of course, that's going to be addition. But we have to be careful because more than and less than are in this little shaded area here because they have to be flipped from what it sounds. So instead of 4 plus n or x, we're going to flip those around so it's x plus 4. Okay. Number 2, 2 less than 1/3 a number. So first of all, find the less than. We know that's going to be subtraction, but because it is less than, remember again, we need to flip it. So another way you can think about it is to go backwards. As soon as you see less than, you can go 2 less than, and then 1/3 a number, or 1/3 of a number is going to be 1/3 x. Or you can put x over 3. 1/3 of x minus 2, or 2 less than 1/3 a number. Number 3, 7 less than the product of a number and 4. So we actually have two operations going on in this one, less than and product. So it might be a good idea to kind of put that in a grouping there. So we know less than is going to be subtraction, okay? And if we go backwards, instead of putting the 7 here, put the 7 here. So it's 7 less than the product of a number and 4. Now there's a couple different ways you can do this. Technically the product of a number and 4 would be n times 4. Remember, anything other than less than and more than will be written in the exact order. However, because we're doing algebra, we will no longer use this dot when we don't have to. So the more advanced way to write this instead of n times 4 would be 4n. So it's still the product of a number and 4. So this would be another time, I guess, when instead of writing it in that exact order, you would put the coefficient in the front where it belongs. Okay. Now, if you wrote this n times 4 minus 7, I would not take off for that. But we're moving in this direction where we don't use the dot unless we have no other option. Okay. All right, 5. The quotient of 5 and the quantity 7 minus x. So once again, we have two operations going on. Quotient, remember, is division. So the quotient of 5, the word and tells you where to put the division. So there's a couple ways you can do this. So the quotient of 5 and, so the and tells you where to put the operation. The quantity 7 minus x. Now quantity pretty much tells you want to use parentheses. And then 7 minus x is 7 minus x. So the quotient of 5 and the quantity 7 minus x. Now the other way you could write this is 5 over 7 minus x. So that's another option. They are both equally correct. You just want to be careful that if it says quantity, that if you write it horizontally, you absolutely need the parentheses. Otherwise, you'd do 5 divided by 7, get that fraction, and then subtract x from it. Now, when it's top to bottom like this is understood that you have to simplify it first before you can divide. So you don't need the parentheses in that case. The next one says the difference of 12 and 3 to the third power. So we see difference. Okay, so that's going to be subtraction. And we don't have to flip any order. So the difference of 12 and 3 to the third power. Okay, the difference of 12 and 3 to the third power. So again, the and just tells you that's where the difference goes, the subtraction in that case. Okay. Next, we want to write an expression for a description, a real life situation. And the first one says CDs cost $10 and DVDs cost $15. Write an expression for the total cost of C CDs and D DVDs. First of all, we're writing an expression, so there shouldn't be any equal signs here. Okay. So the expression for the total cost, you would have to add the total cost of the CDs to the total cost of the DVDs to get the ultimate total cost. So of course, if each CD costs $10 and we're buying C CDs, we don't actually know how many, we would have to take $10 and multiply that by how many CDs that we buy. And we do the same thing for the DVDs. Each DVD costs $15, and we'd have to multiply $15 times the number of DVDs that we buy and add those two together, and that would be the expression for the total cost. So for example, if we bought 3 CDs and we put a 3 in there, that'd give us $30. And if we bought 2 DVDs and we plug that in there, that'd be 30. So then 30 plus 30 would be 60. So this just allows us to plug in how many CDs or DVDs we buy and to find the total cost. The second one says renting bowling shoes costs $3 and each game costs an additional $5. Write an expression for the total cost of G games. So what this is saying is no matter what, if you come into the bowling alley to play any amount of games, let's assume you're renting shoes, because some people own shoes, but let's assume this is a person that's not in a league. They don't own their own bowling shoes. So they're going to start by paying the $3. They have to pay the $3 no matter what. But they're not going to pay that fee multiple times. The fee that they'll pay multiple times is the $5 per game. So if we don't know how many games they're actually going to play, but it's G games, we'd have to take $5 and multiply that by how many games they're actually going to play. So if they play 5 games, that would be $25 plus the $3 that they have to pay to rent their shoes. So we're going to add these two together. So this is what we're starting from. No matter what, you'll pay $3. And then you can leave it up to how many games you play to determine the total cost. So if you had these flipped around, that would also be correct. Same with these. Okay, I like to do them in the order that they read, but they would not be wrong if you have them switched in order. All right. The last thing in section 1.1 is factors, parts of a power, and evaluating. So you've already taken notes on what factors are and what the parts of the power and how to evaluate an exponent. But I want to do some more examples with you so it's abundantly clear. It does say that we need to expand each power first. So 2 to the 6th power, of course, means 2 times 2 times 2 times 2 times 2 times 2. That's what you get when you expand it first. And then after you expand it, then you will write the answer, 64. I didn't use any equal signs. I'm just working down. Okay. Now, -4 to the 2nd power means we're going to take -4 and multiply it by -4. You don't really need the parentheses there, but you can have them. And of course, -4 times -4 gives you a positive 16. Okay. -3 to the 3rd power would be -3 times -3 times -3. And when you multiply those together, you get -27. So no parentheses, no negative, no problem. Parentheses with the negative, still no problem. Same thing, parentheses with the negative, still no problem. This is the problem child here. When you have no parentheses and you have a negative, then here's where the confusion comes into play. Order of operations says that really all you're squaring is whatever's directly to the left. So really, this is the negative of 4 to the 2nd power. When you read this, this is really the opposite of 4 squared. Now, if 4 squared is 4 times 4, we would get 16, and then we have to find the opposite of that, so that would be negative 16. Okay, so it's very important that you pay attention to the parentheses. If there are no parentheses, you're only really applying the power to the number and not the negative sign. And in the end, the negative sign just gets thrown on to the end when you're all done, okay? Make sure you understand this and use your Cornell notes when you get to these examples to remind yourself of how to do those.